A leopard corners a baboon high on a rocky cliff. The baboon screams, charges once, then suddenly exposes its back and lowers its head. The leopard stops. Seconds later, it walks away. On another continent, two male red deer crash their antlers together with enough force to shake the forest. They push, twist, snort. Then, almost without warning, one simply turns around and leaves. The winner doesn't chase him, and beneath the Pacific Ocean, two octopuses spread their bodies wide, darken their skin, and reach toward one another. For nearly 20 minutes they threaten, posture, and test each other's nerve. Neither lands a serious blow. That last one actually happened. Nature is filled with battles, but far fewer of them end with a winner standing over a defeated enemy than you might imagine. Again and again, animals stop fighting before anyone truly wins. Not because they're merciful, not because they're afraid, because in many cases, evolution has made quitting the smarter strategy. The strange part is how universal that rule is. From insects to mammals, from coral reefs to African savannas. Countless species have evolved elaborate ways to avoid the very violence they seem prepared for. The fight is often real, the danger is real, but the goal usually isn't destruction, it's communication. Now go further back to one of the most influential discoveries in animal behavior. Every autumn across northern Europe, red deer begin the rut. It's breeding season, hundreds of males gather. The air fills with deep, roaring calls that echo through valleys before sunrise. At first, almost nothing happens. The stags simply listen. Each roar carries information: body size, age, confidence, stamina. Researchers including Tim Clutton-Brock discovered that males spend far more time assessing one another than actually fighting. Many contests end before physical contact ever begins. One stag hears another roar, measures the risk, then quietly walks away. Even when antlers finally collide, the fight itself often looks strangely controlled. The animals push, twist, test strength, but they rarely stab. The antlers function almost like wrestling grips rather than weapons. That seems odd until you remember what's actually at stake. A broken antler, a shattered leg, a damaged eye. Any serious injury could mean starvation long after mating season ends. Winning one battle isn't useful if you can't survive the winter. Natural selection favors animals that know when enough is enough. Take elephant seals. At first glance, they seem to ignore every rule. Adult males can weigh over 4 tons. When breeding season begins, beaches become packed with enormous bodies competing for control of harems. The largest males slam into each other chest first. They bite. They roar. Blood sometimes covers their necks. Yet researchers notice something unexpected. Most rivals never challenge the dominant bull at all. They simply watch, for days, sometimes weeks. They memorize previous victories. They learn who usually wins. Behavioral ecologists call this the winner-loser effect. Victory changes future behavior. So does defeat. A male that repeatedly wins becomes more confident. A male that repeatedly loses often retreats earlier in future encounters. Eventually, many contests become little more than brief displays because both animals already know how the likely outcome will unfold. Experience replaces violence. Now here's something more familiar. Wolves. Popular culture imagines wolf packs as constant arenas of brutal dominance. Reality looks very different. Long-term studies by biologist David Meck transformed how scientists understand wolf social behavior. Most wild packs are families, parents, older siblings, young offspring. Actual fights inside the pack are surprisingly rare. When tension rises, wolves rely on ritual. One animal lowers its tail. Another licks the dominant wolf's muzzle. Ears flatten, eyes turn away. The body becomes smaller. Submission appears almost theatrical. But it works. The aggressive animal usually relaxes within seconds. No serious fight occurs. Those gestures aren't signs of weakness. They're evolved signals that prevent costly injuries between relatives who still need one another tomorrow. You don't want your hunting partner limping because of an argument over food. Cooperation pays better than victory. Then there are the fiddler crabs. If you've ever watched them on a tropical shoreline, the scene looks almost comical. Each male carries one enormous claw, sometimes nearly half his body weight. He waves it constantly, thousands of tiny flags rising and falling across the sand. It looks like intimidation. Sometimes it is, but often it's something else entirely. The oversized claw is an advertisement. Researchers found that rival males frequently decide whether to attack simply by comparing claw size. If one crab clearly appears stronger, the smaller rival often retreats immediately. No fight, no injury, just information. The claw evolved not merely as a weapon, but as a message. I am probably too expensive to fight. And most of the time, the message is believed. Now go beneath freshwater streams. Crayfish seem far too simple for complicated social behavior. Yet neuroscientists found something remarkable. When two crayfish fight repeatedly, dominance begins changing their brains. Winning increases serotonin activity. The victor stands taller, moves more confidently, initiates more encounters. Losing produces the opposite. Subordinate crayfish become hesitant. They retreat faster. They avoid confrontation altogether. Eventually, two individuals may stop fighting almost completely because their nervous systems have already settled the argument. The hierarchy now exists inside the brain as much as outside it, which raises an obvious question. If animals keep walking away, how do they know when it's time to stop? The answer isn't courage or fear. It's mathematics written by evolution. For decades, behavioral biologists have described conflict using what are called assessment strategies. Every fight has costs: energy, time, risk of injury, risk of death. Every reward has value: food, territory, a mate. The decision to continue depends on comparing those two numbers. Not consciously, not through calculation. Through millions of years of natural selection shaping instinct. If the expected cost becomes greater than the possible reward, leaving becomes the winning move. And evolution quietly favors the animal that survives to fight another day. The mathematics behind that decision became much clearer in the 1970s. Evolutionary biologist John Maynard Smith proposed one of the most influential ideas in behavioral science: the hawk-dove game. Imagine two animals competing for the same resource. A hawk always escalates. It keeps fighting until it wins or suffers serious injury. A dove does something different. It displays, threatens, pushes a little. But if the conflict becomes too dangerous, it withdraws. At first, always being a hawk sounds like the obvious winning strategy, until every opponent is also a hawk. Now every contest becomes expensive. Broken bones, lost eyes, fatal wounds. Soon, nobody is gaining much at all. Surprisingly, a population made entirely of relentless fighters performs worse than one containing animals willing to back down. The most successful strategy isn't endless aggression, it's knowing when aggression has stopped paying. That prediction turned out to describe real animals astonishingly well. Red deer, lizards, fish, birds, even insects. Again and again, researchers found the same pattern. Animals weren't trying to destroy one another. They were trying to gather information. How big are you? How healthy? How determined? How much are you willing to risk? Once those questions are answered, the fight often becomes unnecessary. Take mantis shrimp. They're famous for delivering one of the fastest punches in the animal kingdom. Their clubs strike with the speed of a bullet. The impact is powerful enough to crack aquarium glass, so you might expect every territorial dispute to end in devastating combat. Instead, researchers discovered something much stranger. Before throwing those dangerous punches, mantis shrimp often engage in ritualized contests. They spread their bodies, display vivid colors, then perform what's known as the Telson spar. Rather than striking each other's vulnerable bodies, they hit the heavily armored tail shield of their opponent. The blows are real, the force is immense, but the target is carefully chosen. The contest measures strength while reducing the chance of catastrophic injury. Even one of nature's most destructive weapons is used with surprising restraint. Now go to Australia. Male kangaroos are famous for boxing. They jab with their forelegs. They wrestle. Sometimes they balance on their tails before launching both powerful hind legs at an opponent's chest. It looks chaotic, yet experienced males spend much of the encounter reading one another. Posture changes, eye contact, balance, weight shifts. Many younger rivals abandon the contest before the most dangerous kicks ever occur. The display itself communicates enough. Again, information replaces violence. But if avoiding injury is so valuable, why do some animals fight to the death? Because the rules change. Consider ants. An individual worker has almost no chance of reproducing. Its genetic success depends almost entirely on the survival of the colony. For the colony to live, the individual can die. That completely changes the calculation. Army ants launch massive coordinated attacks with extraordinary casualties. Honeybees sting invading mammals knowing the act will kill them. Termite soldiers block tunnels with their own bodies. The individual loses everything. The colony survives. Evolution counts that as a success. Then there are chimpanzees. Unlike wolves or deer, neighboring chimpanzee communities sometimes wage organized, lethal raids. Jane Goodall shocked the scientific world by documenting one such conflict at Gombe in the 1970s. Small groups of males quietly crossed territorial boundaries. They searched for isolated rivals. When they found one, they attacked together. The victim often had no chance. Researchers have since observed similar behavior in other chimpanzee populations. Why doesn't ritual stop these fights? Because the opponents aren't members of the same family group. They're competitors for territory, food, and future mates. The costs remain high, but the potential rewards can be even higher. The same evolutionary principles still apply. Only the equation has changed. The important lesson isn't that animals are peaceful. They aren't. It's that violence follows rules, and those rules are surprisingly rational. Now here's something even more fascinating. Sometimes animals don't just know when to stop. They know when not to start. African elephants frequently avoid direct conflict simply by recognizing one another. Researchers studying elephant communication found that individuals remember dozens, perhaps hundreds, of other elephants over many years. Age, status, family relationships, previous encounters. A younger bull approaching an older, dominant male often turns away long before any threat is made. There is no chase, no charge, no dramatic showdown. Memory settles the conflict before it exists. The same happens in many birds. Among cichlid fish, even among paper wasps, which can recognize individual faces. Recognition reduces uncertainty. Less uncertainty means fewer dangerous mistakes. In other words, intelligence often makes fighting less necessary. So why does all of this matter? Because it changes how you see conflict itself. Humans often imagine evolution as rewarding the strongest, the fiercest, the most aggressive. Nature tells a more complicated story. Again and again, survival belongs to the individual that manages risk best, the one that knows when to advance and when to leave. The bravest animal isn't always the one still fighting. Sometimes it's the one that correctly recognizes the fight is no longer worth having. That's a profoundly different definition of strength. It also explains why ritual appears everywhere in nature. The roaring deer, the waving crab, the bowing wolf, the color-changing octopus, the boxing kangaroo. Each performance asks the same question. Can we solve this without paying the full price? Most of the time, the answer is yes. And perhaps that's the strangest part. For all the documentaries filled with claws, teeth, horns, and blood, the greatest achievement of evolution may not be inventing better weapons. It may be inventing better ways to avoid using them. Conflict never disappeared. It simply became more efficient. Because every unnecessary injury removes a future parent. Every broken limb weakens tomorrow's hunt. Every fatal victory risks becoming an evolutionary defeat. The animals that filled today's forests, oceans, rivers, and grasslands are not descendants of those that fought every battle. They're descendants of those that survived enough battles to reproduce. Those are not always the same animals, so the next time you watch two stags roar across a valley, or two wolves settle an argument with nothing more than a lowered head, or a tiny fiddler crab quietly retreat after a single wave of an oversized claw, remember what you're actually seeing, not cowardice, not surrender, but millions of years of evolution discovering a simple truth. The smartest fight is often the one that ends before anyone wins.